Everyone. Let's start with the advent of code. Today is day 4 and the problem is printing department. So the problem for today says that there are rolls of paper that we have. So this is the roll of paper. Just a minute. So this is the roll of paper. At the rate is the roll of paper over here. So part 1 here. Part 1 states that whatever at the rate we will have 8 adjacent people around it. So 3, 3, 6 and 2, 8. So among these 8, at most 3 should be another at the rates. So among these 8, at the most 3 should be another at the rates. So what is the method that we follow? First we pass the input. Once we pass the input, what we can do is this at the rate. For every at the rate, we will check its 8 adjacent points. So we will have directions, and here we will have a list of 8 directions. So 0, 1, 1, 0, 1, 1. Then we have minus 1, 0, 0, minus 3, 4, 0, minus 1, minus 1, minus 1, 4, 5, 6, and which am I forgetting? Minus 1, 1 and 1, minus 1. So here we have the 8 directions. So these directions will give us the 8 adjacent points. Of course, we'll have conditions to check the range, which will be between the data length and the 0 point that is over here. But this way we will check if the adjacent points contain at the rate or not. If they contain at the rate, we will have another matrix. So what will this matrix do? This matrix will contain 3, 4, whatever the adjacent at the rates for this pointer or for this problem. If it is the number that we get, if it is less than 4, which is at most 3, we will add it to part 1. No need of the matrix as such. We will add it to part 1. Another method now will be, we will have a matrix, and that matrix will contain the number of adjacent at the rate neighbors that we have. So see, dot has one neighbor, but is not a at the rate, so we'll leave it. So the 0, 2 is at the rate. It has 1, 2, 3 adjacent neighbors which are at the rate. So we'll have 3 over here. So this is how we'll be forming the matrix. And these two will be 0. Alright. So this way we will get the answer for the part 1. Now what the part 2 says over here is, once we remove an at the rate, then we must check if the previous anybody is getting updated. If the neighbors are updated, then we should be able to move the at the rate that was before. So let's check this at the rate first. Handwriting. All right. So as we can see, this at the rate has 4 adjacent neighbors, right? Now this at the rate has how many? 3 adjacent neighbors. So what we are going to do? We are going to remove this at the rate. Now what happens is, this at the rate should get updated to 3 adjacent neighbors. And then we should remove this at the rate too. So this is the process that they want us to follow for the part 2. For the part 2. So how will we do it? So last question, you remember we had a matrix. We had directions and we had a matrix. So in this matrix, if you remember, we had, for every at the rate, we were saving how many adjacent at the rates they have. Now this can be 0. This should be placed, this has 3. Let's take it as 0. And then we'll have 2 over here. Let's give it 3 over here. And 1, 2, 3. And suppose this guy has 2. And this guy will have 1, 2, 3, 4 at least. Let's take this as 0 for now. Okay, now let's check. We iterate from here. We check this. It is not here at the rate. We check this. Yes, it is at the rate, but it is greater than 3. That is, it is not less than 4. Now we check this. Oh, this is again an at the rate, and yes, it has neighbors less than 3. I'll have to remove this. I'm sorry. 1, 2, 3. Okay, my bad. Okay, 1, 2, 3. And this guy is 1, 2, 3, 4. But this 3 we'll check. This 3, yes, it is an at the rate, and yes, it has how many neighbors? 1, 2, 3 neighbors that are at the rates. Once we get this, we will remove it. So what do you mean by removing it? This will go to 0, and this guy will get updated to 3. This guy will get updated to 3. This guy will get updated to 2. Now we take our I and j back, because we know that the elements which are I minus 1, j minus 1, this is the diagonal element to here, but here as the element is not there, it will take here. If we were here, it would have taken us over here. So from that element we'll have to check again, because only this is the most non-recent element that we had visited, and it is updated. That is why we visit over here. That is I minus 1, j minus 1. Alright, so let's check the code for this. Here I had the inputs, and yeah, we got 2 stars for this. So the code for this today is a bit lengthy. Just follow, you'll be able to get it. Now this takes the input, so we are passing the input over here. Once we pass the input, what we have over here is we are preparing the matrix. You don't need the matrix for 1, but as we will be preparing the matrix, that is why we passed it into 1 and used it to get the answer, and then we will be using it for part 2, as we will be changing the matrix a bit. So the first function that we'll call is this one, part 1. So in part 1, we'll be adding to the matrix. What we'll be adding to the matrix? The row of the data, and in this row we'll have the ith row. So the ith row is known as row. in that row we'll have j, and that j will have value. If that value is at the rate, what we are going to do, we are going to compute add to matrix. Add to matrix, what do we have? We have 8 directions over here. In these directions we check, we matlab, if we have at the rate over here, all these directions we'll be incrementing them by 1, plus 1 plus 1 plus 1 plus 1 everywhere. So that is the logic that we have had in add to matrix. Once we have added to matrix, we just have to check. Now what do we have to check? If the data ij is at the rate, and if the matrix is less than 4. Once it is there, we'll add it, and the sum of that will return. That will be the value for part 1. So part 1 was simple. Now the second one, that is part 2. In part 2, what do? We have an I pointer, a j pointer that iterates through the data. So while iterating through the data, we check. What do we check? If the data ij is at the rate, and in that matrix, if we have something less than 4, if these two conditions are satisfied, we have to update the matrix. How do we update the matrix? We sub from matrix. This is all done in place. So what do we subtract from matrix? Again, we have the directions. In these directions, what we'll do, we'll get that matrix I comma j, and we'll subtract from it. You can have both of these functions as common. Just I have an input as +1 or -1, and you can update this. So that is one way. If you want to reuse the function, that is one way that you can do, but this is also fine. Yeah. So we subtract the neighbor, because at the rate which was in between this is now gone. So the neighbors must be subtracted by 1. If the neighbors are subtracted by 1, which is the neighbor, which is the least recent neighbor visited? So this is the least recent neighbor visited. This is the most recent neighbor visited. These are the neighbors not visited. So this is the least recent, then 2, 3, 4. That is how we go. So once we subtract, now what do we do? We'll add the one at the rate, or one paper we have removed. So we add 1. Now this data we'll update it, because now there is no paper over there, and once the paper is not over there, we will jump back. Okay, we will jump back, and once we jump back, we'll check these things again. We'll go through the loop. We'll increment I, we'll increment j, then finally we read in part 2, and that is how we get the answer for part 1 and part 2. Alright, so Advent of Code has some pretty good questions. Today's question, I would rate it as an easy to medium level, between that. Try it out. If you have any other approaches, please feel free to comment down. It will be really helpful for all of us. Alright, thank you.